All right, guys. Yeah, my name is Ross. I'm a tech lead with the Developer Student Club, um, and I'm a FAU student like most people here. But without further ado, I'm going to get started with the event. Today, we're going to be covering cloud functions. But before I go into those, I want to talk a little bit about what serverless computing is, because cloud functions are a serverless computing process. We're going to introduce what cloud functions actually are and some of their applications. And then for the remainder of the event, we're going to build our own HTTP cloud function using Python. So at the end of this, I hope that you'll understand what HTTP cloud functions are, how to write a cloud function using Python, how to write a cloud function that takes in arguments, how to write a cloud function that returns an image. And if we have time, we'll learn about how we can test and view the logs of the cloud function. So you may have heard about serverless computing. It's kind of a big buzzword right now. And I figured it's important to talk about what serverless computing is before we dive into cloud functions. So a lot of people are using serverless computing because it allows the developers, us, to focus on writing code and applications instead of managing the server infrastructure. So if you're using the Google Cloud Platform and you're using a serverless option, the infrastructure is going to be fully managed by Google, so you can focus on the code. Google is going to be responsible for the security, maintenance, the availability of the infrastructure, which is a couple, less things you need to worry about. All data is encrypted at rest and in transit, so that ensures your data can only be accessed by you or the people you authorize. And so it's likely more secure than anything you need to come up with yourself. So in the data centers that run the cloud functions are physically secured with several layers of security. Just a side note, they actually have a moat with like alligators around the building that secures all their infrastructure. Another big thing with serverless computing, probably one of the second, pros to serverless computing is auto scaling, and that's huge. With auto scaling, you only pay for what you use and what you need. Also, with the serverless computing platform, there's no upfront provisioning, so you don't have to set regions or the amount of CPU cores or work on the operating system. So, and there's zero server management. There's several serverless products by Google. Today, we're just going to focus on cloud functions. So serverless computing, that actually uses a server. In case you didn't know, that there's actually hardware. It's just that to us, the developers, it's serverless. So why use cloud functions, or more importantly, like what are they? So basically, cloud functions provide a connective layer of logic that lets you write code to connect and extend like pre-existing cloud services. So you can listen and respond to, say, a file upload in cloud storage, or a log change, or an incoming message. Cloud functions can be written in Node.js, Python, or Go. Those are the three languages they can be written in so far, and they're executed in a language-specific runtime as well. So cloud functions expand the capabilities of existing cloud services, and you can address like an increasing number of use cases with custom programming logic. So very rarely would you write a cloud function that as your main application. It's usually to enhance a pre-existing application. So another reason why you'd use cloud functions is, say you have an application that's running on a single machine, or just a cluster of them, and one or more of the machines goes offline. Your application could be slow or go completely unavailable. If you're using cloud functions, if the machine goes offline, Google quickly will spin up a new instance to replace it. which can cause very minimal downtime, making the application highly available. Cloud functions remove the work of managing servers and configuring software or updating frameworks or patching operating systems. So you don't need to create a whole new server architecture just to execute one function for your application. You can just write the function like you would write a normal function in whatever language you choose, if it's one of those 3 languages. And so all the provisioning of resources happens automatically in response to events. So that means the function can scale from a few calls a day to millions of calls a day without any work from us. Google just automatically scale it for us, and we just pay however many times that cloud function was invoked. So a couple use cases of cloud functions. One of the big ones is data processing. So like I said, you can listen to, say you have an application that uses cloud storage. You can listen for events such as if a file is created or changed or removed. You can also use them for webhooks. So a simple HTTP trigger can respond to events originating from third-party systems like GitHub or Slack, or anywhere that can send HTTP requests, which is a lot of places. They can be used to make lightweight APIs. So you can compose applications from lightweight, loosely coupled bits of logic that are quick to build and scale almost instantly. Also, a huge use case for cloud functions is the mobile backend. So you can use Google's mobile platform, which is Firebase, and write your own mobile backend with cloud functions. And so you can listen and respond to events from Firebase. So for example, say I was developing an application, it was a social media site, and users could talk to each other through the app. But I wanted a user to be notified when one of their friends is online. I can make a cloud function that basically sends the other user a notification, just a notification badge that says, hey, so-and-so is online. So that's one use case for a cloud function. They're also used in the Internet of Things. So imagine tens or thousands of devices streaming data into cloud storage, and you can launch as cloud functions to process and transform and store data. So all of this with cloud functions lets you do so in a way that's completely serverless. Now, when it comes to these cloud functions, there's 2 very big ideas that it's kind of important to understand. And those are events and triggers. So things like changes to data in a database, or files being added to a storage system, or a new virtual instance being created. Those are events. So event is really just anything that happens in your environment. So anything that happens is an event. Those kind of are synonymous with each other. And a trigger is a response to an event. And what you can do with cloud functions is you can bind a function to a trigger, and it allows you to capture and act on events. So like I said, if someone were to log in, your function can run and be notify the other user that someone is online. And these functions are honestly the combinations and variations are pretty much as vast as what you can program with your language of choice. So in our case, we're going to focus on a trigger being a URL endpoint. But there are 2 types of triggers, and triggers determine how the function executes or when the function executes. So essentially, what occurrence should cause your function to run. And when you associate a trigger with a cloud function, your function will execute when the trigger fires. So there's 2 types of triggers. There's HTTP triggers and event triggers. Event triggers are primarily used in background functions, and those respond to events that occur within Google Cloud. So like things that changes to data in a database, or files being added to a storage system. Those are examples of a background function event triggers. But then there's the HTTP trigger, and that has a URL endpoint, and they're called with HTTP requests. And that's what we're going to be doing in today's event. We're going to build some cloud functions that use an HTTP trigger. So the remainder of the core, today, we're just going to build out 3 functions. We'll be using the cloud function with Flask. Flask is a lightweight Python framework that lets you develop a web application. You don't need to have any experience with Flask to do this event. And really with Python too, because the functions that we're going to write are very rudimentary. So, and I'll let you know what's specific to Flask and what's specific to Python and what's specific to cloud functions. So it doesn't, you'll see when we get to the functions, they're pretty self-explanatory. So after we write the function, we're going to deploy the cloud function using Google Cloud's command line utility, which is Qcloud. And then we're going to see the cloud function in action. And like I said, if we have time, we'll monitor the logs of the function we just created.
Hey everyone. The Qwiklabs Platform is a hands-on lab platform designed to allow students to learn and practice cloud technologies, including Google Cloud products. Qwiklabs has over 500 labs covering topics ranging from compute engine and functions to Google Kubernetes engine and machine learning. Each lab gives you a brand new temporary Google account with access to the Google Cloud Platform so that you can complete tasks that reinforce your cloud skills. This also ensures that you don't have to pay for resources you use while you're learning. Quests are collections of related labs that target a specific role or product, and upon completing a quest, you can earn a skill badge. At the end of the lab's timer, your lab and any resources you use during the lab will be deleted. But don't worry, if you can't complete the lab during the allocated time, you can always start the lab again. By participating in developer student club events such as this one, you get free access to the Qwiklabs platform. In order to get free access, you need to attend one of our events live. Because you're watching this after the fact on YouTube, we cannot give you credits or free access here. Please check our website at dscfau.com/events for upcoming events, or join our Discord server at dscfau.com/discord. Feel free to send a message to one of our officers if you're interested in learning more about Google Cloud. This event utilizes the Qwiklabs platform to give attendees hands-on experience with cloud functions. An important note, you absolutely need to be using Incognito Mode for anything you do in Qwiklabs. There are 2 main reasons for this. Number 1, this ensures that you don't accidentally build your own Google account instead of the Qwiklabs one. There are some charges associated with running stuff on Google Cloud, but with the Qwiklabs platform and as a student, you don't have to pay for them during the labs. By using Incognito Mode, you also add an extra barrier between your Google account and the Qwiklabs provided account. This ensures that you're not signed out of your personal or school account at the end of the lab, which will happen if you use your primary browser session. With that said, you can access the lab used in this event by visiting go.dscfau.com/functions in an Incognito tab. Once you're there, you can sign into a Qwiklabs account, but try to avoid using the sign in with Google feature. If you do not have a Qwiklabs account, you can use the join or create an account button to create an account. For the company field, you can put NA or DSCFAU. Once you're logged in, you can click the Start Lab button to follow along with us.
So you'll be here at the Google Cloud Platform dashboard. And this is everything that, so if you ever have used Amazon Web Storage, this is like the equivalent dashboard, but in Google. And from here, this is not specific to Google Cloud functions. It's the cloud dashboard. So if you want to set up a Maps API for your mobile app, you would come here. If you wanted to set up a Kubernetes engine, you would come here. but we're just doing cloud functions, and we're going to do it through the terminal. So you'll see at the upper right-hand side a little icon that says Activate Cloud Shell. Just go ahead and click that. Hit Continue. And then it's just going to provision the Google Cloud Shell. Now, since this lab is based off cloud functions, the Cloud Functions API is going to be enabled by default. So we don't need to enable that API. If you were to do this cloud function or make a cloud function on your own, you'd have to enable it. And it's just a really simple command. I'll do it here just so you're aware. I don't want to scare anybody. It's not going to give me any output, but this is how you would enable it. I authorize it. That's just saying Google can make API calls on my behalf. So the next thing we're going to do, you'll see this Open Editor button right here. Click that. And it's going to say Open in New Window. And press that. Is anybody having trouble getting to where I'm at now?
I missed what you did at first. Open API, I think.
Was it the command that I wrote?
No, before that.
Did you get to this screen, this Cloud Shell or this terminal?
No.
Okay, you'll see, do you see an icon up here? It's like a box with an arrow and an underscore.
Yeah, activate Cloud Shell. It's connecting. Okay, I'm there.
And then hit this Open Editor button. And open a new window.
Got it.
And this is basically, if anyone's used VS Code, it's just a VS Code text editor that runs in the browser. So our first cloud function, we're going to write, and the goal of this cloud function is just to respond to a URL, an HTTP request, and it's going to respond with the string hello world. And this right here is the entire function. Like, that's it. That's the first function we're going to write. All the code available for the series is going to be in this link up here in this green bar. And Ben can probably put that in the chat. And it's just links to a GitHub gist with all the code. So we're going to start. We're going to make a new file. And we're going to call it main.py. And it has to be called main.py. So all underscore and just press enter, and that's going to create a new Python file. And so all we're going to do here is just write the function, and then to define a function in Python, you just use the keyword def, and we're going to call the function hello world. All undercase, and it has to be written just like this. And we're going to give it one parameter. We're going to call it request. Make sure you have the colon at the end. And we're just going to return a string. It can be any string. We're going to call it hello world. That's kind of convention for, you know, a first program. And just hit save. And that's the entire function. So you notice we're not using the request parameter for this function. We will a little later. We don't actually need it. And this could run just fine, but it's good practice to just keep it in. Because in the future, when you make cloud functions, you'll use the request parameter. And the request parameter is a request object that contains details about the request. And like I said, you'll see an example of that coming up. So now we're going to deploy the function. And this is the command, and I will type it out for you guys. So if we go back to the terminal, make sure you hit open terminal. And just type in Qwiklabs functions deploy. The name of the function, which is hello world, and it has to be spelled exactly like we wrote it earlier. And it's going to take, this command is going to take a couple arguments. These are command line arguments. The first one's -- runtime Python 37, and then -- trigger HTTP -- allow unauthenticated. And I'll explain this command a little bit more. So I'm just going to give everybody a chance to type it out. I wonder if I can just copy that. I'm going to press enter, and I'll explain. I spelled unauthenticated incorrectly. Real quick, I'm going to just see if I can. Oh, okay. Someone already put that in the code or in the chat. Thank you, Ben. So right now it's building the function and deploying it. And I'll just go over that command. It's kind of long, so I'll just explain it. Runtime, the runtime portion is just specifying how we want to run it. In this case, we're going to use Python version 3.7. The trigger HTTP creates the HTTP endpoint. So the result of the function execution will be returned in an HTTP response. In this case, the string hello world is the HTTP response. And the allow unauthenticated flag allows us to reach the cloud function without being authenticated. So it's gonna build for us. It takes just a couple seconds. While we wait, does anybody have any questions? All right, so here's the output of the function. It's quite a big output. We're only concerned right here with this HTTPS trigger, and it creates a URL for us. Now, if we go to that URL, I just hit Command click or Control click if you're on Windows. And there we go. By going to this URL, a string is returned, hello world. So what's happening here is that when a request is made, in this case, a GET request to that endpoint, this function will be called and ran, returning the string hello world.
All right. Just to make sure, everyone is on Qwiklabs and you're able to access everything.
Yeah. Hey,
Okay.
Ross. My link that I got from the terminal didn't give me the exact result that you got.
What do you see?
You may have to scroll up. What?
I'm using a Mac. I got this XML file does not appear to have any style information associated with it. Documentary.
So yeah, there's a couple URLs it gives you. Make sure it's the HTTPS trigger one. I highlighted it. If you look at my screen, it's.
Okay, I think I see it.
Yeah, so the function URLs will always be the region dash your project name, which is unique for like a globally unique thing on Google Cloud, .cloudfunctions.net / hello underscore or / your function name. That was a question. Oh, I thought you said, was that the first code? Not what was it?
Ross, there are two questions in the chat. The first one was, what does that command do? Could you explain how the command operates?
Okay, I'm going to address Clark's question. That command that I did enabled the Cloud Functions API. You can ignore that though. I shouldn't have even put it there. The API is enabled by default. I'm just saying in the future, if you do your own Cloud Functions, you'll need that command. But you can always Google that command later, but you can just ignore that.
To explain how that works in a larger sense, when you create your own project outside of Qwiklabs, everything is disabled by default. And if you want to use a service, you have to enable it and enable billing for that service. Otherwise, you don't get charged because nothing's running. So you can use that command to enable it. You can also do it in the console. And I think we're going to go over how to do that stuff later with a future event in the summer.
All right, so, and Mustafa, what's happening here is basically an HTTP Cloud Function. You've ever coded, you define a function, then you call the function, right? And you call the function, the function runs. What we're doing here is basically just accessing that URL calling the function. That's what's making the function run. In this case, returning a string, hello world. I think the next Cloud Function we do is going to be a little bit more, provides a little bit more insight. And so we're going to make another function. If you guys didn't get the last function, it's fine. Just we can worry about that later. We're going to use arguments in Cloud Functions. This is the function that we're going to be writing. I'll type it out. So don't worry if you don't catch everything now. You'll notice that we're going to use the Flask library. You don't have to understand Flask for this event, but I will show you why we need to use it. And we will now be using the request parameter that I discussed earlier. So the request object is an HTTP request coming from your browser. And the request.args is a dictionary that contains arguments in the URL, also known as parameters. So the request contains details about the request made at that endpoint. So if we call the args property on the request object, we gain access to the query parameters that show up in the URL, if that makes sense. We'll show you an example of what the query parameters are, but just think of request args as a dictionary with the key value pairs of the query parameters. So I'm going to go ahead and write this function out. So if we go back to the text editor, we're going to keep the function name the same. But we're not going to return hello world. We're going to import the Flask library. And we're going to make a new variable, and we're going to call it request_args. So this is a new variable. And we're going to set it equal to request.args. So we're just going to access the argument properties in that request object, which is here in the parameter. So we're going to check. We're going to say if request args and name in request args. What this is saying, we're saying, does request args exist? Is that there's data populated? And if so, does the name value exist, right? So the name is going to be like the query parameter. And again, you'll see an example of what that means. So if those two conditions hold, we're just going to make a new variable, and we're going to set name equal to request_args. And this is how you access a Python dictionary value. Just use indexing and then the name of the key, which is name. If that doesn't hold, we're going to set name equal to the string world. And at the end, we're going to return it. We're just going to use simple Python formatting, string formatting. So you just write the string and then dot format, and it fills in whatever in the curly braces. So in this case, we're going to call the Flask function Flask escape and pass it that name variable. Okay, and this is why we're using Flask here. This doesn't even we don't even have to use Flask. We don't even have to use Flask escape. All it does is just converts like special characters like ampersand signs and less than or greater than signs to HTML safe characters. So if users were to enter that in the URL. So hit Control Save or Control S. Sure.
Russ, there's a question. What is Flask? I don't know if you mentioned that.
Oh, yeah. So Flask is a Python library for developing web apps or websites with Python. So if you know, Python really isn't inherently a web development language. It's a library that lets you create an HTTP server and host content. Think of it as like a backend written in Python. There's also Django, which is the corresponding, like there's Django and Flask are the two big Python backends. There's also Fast API, which I think is pretty new, but honestly has a lot of potential. So since we kept the name of the function the same, we just go back and we can reuse that deploy command. Just press the up arrow key and just press enter. That's why we kept the function name the same. It makes things a lot easier. So it's going to give us the URL again, that HTTP trigger. It's going to be the same URL as last time. You'll see that it just says hello world because we didn't pass in any query parameters. To do so, you just hit question mark, the name, name value pair, the query parameters. We're checking for name, so I'm just going to set name equal Ross, and it should return Ross up here. And you can just type in whatever. Those are what we mean by query parameters. Yes, it's actually very simple how it does that. But if you guys are a little confused, I just want to talk about query parameters. The query parameters just provide additional information about the request. The parameters show up in the URL bar, not in the request body. So they're not encrypted. Even when using HTTPS, they're in the form of key value pairs. And each key and value are separated by equal signs. And these key value pairs are separated from each other using an ampersand. And you'll see this a lot in pretty much every website you go to. And the question mark is placed at the beginning of the query string to specify the start of the query parameters. And then that would be the final URL. Right, so up here, what this is saying is that's just finding whatever in the URL for us. The request.args was that key value pair, right? And we're just checking to see if name exists. And if it does, set it equal to whatever we wrote in there. In this case, I just wrote name equal bunch of random characters. If you guys are curious, the next function we were going to write just returns an image instead of a string. So if you guys are curious, you can always get with me after, and I can point that out on how to do that. There's the code for that. Again, just let me know if you want it, and I can explain it and deploy it the same. But yeah, that's pretty much it. So like in a nutshell, cloud functions are serverless. You only saw like one use case, very small use case for them, an HTTPS trigger. Those are the easiest to highlight, but they can be used for just about anything. It's just really whatever you can code up, right? Here they're triggered by events. Actually, all cloud functions are triggered by events. And there's two types, HTTPS and background, and where the HTTP ones respond to requests.
Hey everyone. So during this event, we deviated slightly from the lab instructions on Qwiklabs, but because you did cover the main topics of the lab, we want to make sure you get credit for the lab, and this way it shows up when you try and complete or work towards a quest badge. So basically, we're going to go into Cloud Shell and run this command. So once you're in Cloud Shell, go ahead and type curl space dash lowercase s uppercase L and then go.dscfau.com/fc, and then we're going to hit the pipe key, which is above the enter or return key, and then we're going to type in bash. And what this command is going to do is it's going to delete the function we created during the event, and it's going to deploy a new function that the lab asks us to deploy, and in this process it will create a cloud storage bucket. Once the command is finished, go ahead and click the orange button at the top right of the screen that has a dash and slash and then 100, and this will bring up your checkpoints page. And then for each of the two items, click on the check my progress button and then hit OK. And now you'll see that you have completed the 2 check marks required to get credit for this lab. So once you're done with that, go ahead and hit the end lab button and optionally review it, but you can just hit cancel if you don't want to.
Thanks for watching. We hope you enjoyed this video. To learn more about the FAU Developer Student Club and stay up to date on our events, visit dscfau.com or check out our Discord server at dscfau.com/discord.